Good morning. Thanks for coming. This roundtable, as you probably saw when you went on the line to register, this roundtable is part of a series of 8 roundtables that we're having this fall. So we completed 2 last month, and now we're into October, so we've got 6 more this month. So it's going to be a busy month. Kim Morrow, my assistant, has been helping with these, and so I thank her for all of her assistance and so forth as we put these together, but it's keeping us pretty busy. And then on top of that, in mid-November, we're hosting a workshop on the implications of changes in the Arctic in terms of sea ice on mid-latitude weather in the central United States, and so we're keeping busy with stuff. So anyway, but I welcome you. I'm glad to see the representation from so many different campuses and so on. And our goal with each of the roundtables is really to begin to establish a network so we have stakeholders talking to stakeholders. And so I hope that there will be some longevity to this group, and it'll grow in terms of numbers, and they'll keep talking via email, but also in periodic meetings to share ideas about what's happening on your various campuses related to sustainability issues, adaptation and mitigation of climate change issues, and so forth as we move forward. As Probs mentioned, in September of last year, we released a report. It was called "The Understanding and Assessing Climate Change Implications for Nebraska," and the person that's kind of indirectly responsible for this conversation is sitting over here at this table, Senator Ken Haar, one of our state senators. He started a dialogue within the legislature, and for those of you that are local, may remember a lot of editorials in the newspaper and other articles about the state actually looking at the issue of climate change in this very conservative state that we live in. And but anyway, the byproduct of that discussion was that the university stepped up and actually produced this report. And since that time, the reception of this report has just been incredible. The number of groups that we've been invited to talk to about this issue that are interested in moving forward, being advocates for change, both adaptation as well as mitigation, has really been very rewarding to the 4 of us that served as authors on this report. So I'm going to give you a relatively brief overview of the report and some of the key findings and in terms of its implications for Nebraska. What are we seeing to date, and what do we expect to see in the future? But before getting into that, it's important to talk about the science and talk about some of the key issues that I think are oftentimes misunderstood by people, because few of you are scientists in the sense of you're not climate scientists, and so this is a very complex issue. And so it's easy to dismiss that and for people just to say, I don't believe in climate change. This is about science, and that's where the discussion is. Oh, she's telling me my name tag is. Okay, yeah, I am on video, so she's telling me to straighten up. Okay, so let's get into the subject. If you haven't seen the report, it's available in a PDF form online at go.unl.edu/climate change. So it's actually on the same site. We've modified this original site to incorporate all of the roundtables that we're going to be having over this period of 2 months. So you can download the PDF. There's also a copy of the slides, because I presented this report at one of our Heerman lectures last September. And so that presentation is on this website as well. And in addition to that, the executive summary, which is part of the report, but it's also there separately, and so on. You had an opportunity to pick up some copies of some of the slides that I'm going to be using. It was just a partial grouping of the slides, but it'll be something you can take home. And I think that in combination with the executive summary, which is on this site, but also Prob sent out a document yesterday to all of you, and incorporated in that document is the executive summary for this report. So you can look at those slides, and it'll help to remind you of some of the key points that to be made. So there are a series of key questions, I think, when you start talking about climate change. I gave a talk recently in Omaha to a Rotary Club. And so I started off and I said, you know, is the Earth's climate changing? And I said something like, well, you must have lived under a rock or in a cave if you haven't noticed how the climate of the Earth is changing and has changed in recent decades. And a woman in the front row said, well, I've lived in Omaha all my life. I haven't seen any changes at all. So she's obviously one who's lived in a cave or under a rock. So it's hard to respond to things like that. But as I go through this, we'll talk about some of the changes we've seen as well as projected changes which are of grave concern. So the second question is, are humans the primary cause of the changes that we're seeing? And the reality is that the evidence is overwhelming, not only that the climate is changing and changing dramatically, it's changing at different rates for different regions of the world because there are different climate controls that are affecting the climates of these different regions. But it's also primarily changing because of human actions. So it's what we're doing in terms of modification of the atmosphere. So the two drivers that we talk about the most, we hear about the most, are changes in greenhouse gas concentrations, and we'll talk about those more in a few minutes. And then also changes in land use, because changes in land use change the albedo or the reflectivity of the Earth's surface. And the result of that is it has effects on heat balance and so forth. So the question is, how do we respond to these changes? A lot of the early discussion about climate change, if you go back to the first report of the Intergovernmental Panel on Climate Change, which you may have heard about, they issue a report through the United Nations about every 6 or 7 years. The focus of that initial report was primarily on mitigation, because with mitigation we're talking about reducing greenhouse gas emissions and therefore reducing concentrations in the atmosphere in order to reduce the amount of warming that we expect to see in the future. So there was a lot of emphasis initially on the mitigation and what we're going to do about greenhouse gas concentrations in the atmosphere. Gradually, though, the topic has turned to not only mitigation but also adaptation, because the climate is already changing and we're already adapting to it, and we're going to have to continue to adapt to it. So we need to employ both mitigation strategies as well as adaptation strategies today as well as in the future, and they need to be applied both locally but also nationally and globally. And so most of you are aware that there's a huge climate convention coming up in Paris in December, in which the global community is going to come together once again to try and agree on various kinds of restrictions in terms of release of carbon dioxide and other greenhouse gases into the atmosphere. So this conference coming up in December is a really critical one if we're going to begin to get a handle on where we're headed in terms of these changes. So if you listen to some of the deniers of climate change that say they don't believe it or that it's not happening, these are some of the bullet points that they give as to why they don't believe in climate change. They say that, well, the climates have changed before, so this is just all a natural process. Well, it's true that climates have changed before, and this has been driven by natural forces, natural forces and forcings in the atmosphere. But what we're talking about now are human forcings that are causing changes, and over a much shorter time frame. The changes that we've seen in the past, where we've gone from ice ages into warm periods and so forth, have taken place over thousands of years. We're talking about changes over decades. And the rate of change is a huge concern as to how quickly we can adapt to and to what extent we can actually mitigate some of these changes in the future. Some will say it's the sun. We're getting more energy from the sun. That's why the Earth is warming. There's no consensus amongst the climate community, and that's not true at all. All of the studies show there's consensus within the climate science community on this issue. Some will say it's cooling. Some will say that the models are unreliable. We'll talk about that in a few minutes. That the temperature record is unreliable. That animals and plants can adapt. They can, but can they adapt to these changes as quickly as they're going to be occurring? In the past, where they've adapted over tens of thousands of years, now we're talking decades, a century, and more. So very, very rapid changes. And then it hasn't warmed since 1998, which some of the graphs that you may have seen in the past showed a plateauing of global mean temperature. There's been a reanalysis of that data, and it shows that, in fact, there hasn't been a plateauing of global mean temperature over the period since 1998. Antarctica is gaining ice. So my comment to that is everyone's entitled to their own opinion, but not their own facts. And so it's important that we look at this issue from a scientific perspective and not look at it based upon emotions or the politics, because this is, as you know, has become a huge political issue in the U.S. So to this issue of consensus, there have been quite a few different reviews of the literature out there amongst climate scientists and so on, and those show that 97 out of 100 climate scientists agree that not only is the Earth's climate changing, but that humans are the principal cause. So there's a huge misperception within the community about this because of the fact that the media portrays this differently, and so it confuses the public, that they think that the science community is split on this issue, where in fact they're not. And there was a study that was done actually this last year that looked at peer-reviewed journal articles that focused on the issue of climate change during 2013 and 2014. And the author of that study reviewed 24,000 peer-reviewed papers and only found 4 out of 24,000 that are actually denying that climate change was real and that humans are the principal cause. So the percentage is really close to 100%. There are a few out there that don't accept this, but very, very few. And it's not necessarily that they don't accept the fact that the climate is changing or that even that humans are the principal cause, is they disagree on some of the projections or other things like that. So again, the disagreement is very, very minimal. We had a gentleman from Yale University on campus last spring, Tony Leiserowitz from Yale University. And Tony heads up a climate change science communication program at Yale. And he's done a lot of surveying of the American public. And he gave a talk on climate change in the American mind. And he sort of classifies Americans with regards to what their beliefs are with regards to climate change. But one of the things he did in the lecture that he gave on campus last March was he summarized the issue of climate change into 5 truths, and he did it in 10 words because of the complexity of this. And so I think it's interesting to sort of go back and take a look at that. So the first 2 words were it's real. Secondly, that it's us. Third, that it's bad. Fourth, that scientists agree. And finally, that there's hope. But the hope is really based upon the fact of whether or not or how quickly we're going to actually move to try and control greenhouse gas emissions and concentrations in the atmosphere. So climate change has really become a moral issue. It's a moral issue because of the fact that those that are going to be most impacted are those that have the least resources to deal with this problem. So whether it's developing countries, whether it's the poor in the United States and other countries, in developed countries and so forth, these are the people that are the most vulnerable. And so trying to deal with this issue globally as well as locally and nationally is a huge challenge because of the moral aspects of this and who's going to be affected. We're all going to be affected, but some of us are going to be better able to respond because we have more resources available. So it does present a dilemma. So the Pope's encyclical, which we've heard a lot about since this summer when it was issued, and then with his visit to the U.S. in the last week or so, that encyclical really talks about the moral nature of this particular issue and how it's going to affect people. So my perspective on this is that it's time to really put the emphasis on the science and remove emotion and politics from this discussion and talk about what we're going to do about this. What are the solutions? And we need to talk about it at all different levels. And so these 8 roundtables that we're having are really focused on various sectors. So one of those sectors would be college campuses, higher education. Ken Harr and I were just talking a few minutes ago. He'd like to do a roundtable for K-12, and he's well connected to that group, and so maybe we'll add one that focuses on that level. There's a dangerous trend in the United States, particularly of this trend that's called denialism. And this book, you might want to pick it up. It's a paperback book. It's easy to read, where the author talks about how decisions, or what he refers to as irrational thinking, are being based upon emotions instead of on science. So discussions in the book about GMOs, for example, discussions about immunization of children and so on. So the science says one thing, but there's a huge debate, emotional debate around the subject, even though the science doesn't support some of the conclusions. So this issue of denialism is an important one, and so in the case of climate change, it fits this very, very appropriately, because we are, particularly in a political realm, denying that this is occurring, and therefore we're not taking action. And the longer we delay, the more serious this is going to get, and the less reversible it's going to be in terms of the future. So what I'm going to try to do is to sort of assemble the pieces of this climate change discussion for you. And if you've ever been to IKEA, you can relate to this slide. I hadn't been until a couple of years ago, and it's an interesting place to visit. I try to get out of there as quickly as I can. So first of all, introduction and background. I think it's important that we start by talking a little bit about definitions. And these are key definitions, because one of the most important points in terms of the confusion that's associated with climate change is people get confused between what's weather and what's climate. So weather is a condition of the atmosphere at a particular place and time. You know, it's defined by cloud cover, whether it's sunny, whether it's raining, the wind speed, temperature, all of those various things. And it's very highly changeable from day to day, hour to hour, week to week, month to month, and so on, year to year, and so forth. Whereas climate represents a composite of weather over a period of time. So it's an average. So when we're talking about climate, and we're talking about climate change, we're really talking about trends. What are we seeing in terms of the trends with regards to temperature, precipitation, and other key climatic variables? Mark Twain once said, climate is what you expect, weather is what you get. So, you know, when we see the forecast at 10 o'clock in the evening news, they're talking about the weather forecast for tomorrow or for 10 days into the future. Climate is really, you need to look at that over a much longer time scale. And so when you do that, you get a different perspective. So why is climate so important? Well, climate's important because it determines the distribution of plants and animals, which crops we can grow where, based upon the extremes as well as the temperatures and precipitation that's available. It's important in terms of how we design buildings. It's important in terms of landscaping, what we plant. It just affects everything. It's the driver for everything. And a key point here is what I have at the bottom, stationarity versus non-stationarity. The assumption has been, from a planning perspective, that the climate is stable. That yes, the temperature and the location varies from year to year, month to month, obviously. But if you look at a long-term time scale of 30 or 40 years, that the climate, while it varies year to year, it's stable over time. So if you're going to build a dam, create a reservoir, if you're going to design a storm sewer system, if you're going to build a building, and so on, you build it to certain standards based upon the climate, the heating, air conditioning system, HVAC system, and so forth, because you assume that the past is an indication of what the future is going to be. All of the studies that have been done recently say that stationarity is dead. The future is one of non-stationarity. So the climate is changing, and so the history, past climate, is not indicative of the future. So if we design things based upon the climate of the past, we're going to be making mistakes. So it's important to take into account, yes, what has happened in the past, but also look at the scenarios for climate change for the future and design accordingly, because things are changing. Probable maximum precipitation. All of these things are changing, and it's important to take those into account as we move forward. So, climate change science. So earlier I mentioned that there are natural forces that affect the climate, and one of those myths that were up there was that the climates have changed in the past. You know, yes, they have. They will continue to change in the future because of natural forces, because those are continuing. And so when we talk about ice ages and warm periods, we're talking about things like variations in the Earth's orbit, wobbling of the Earth on its axis, and so on. Again, these take place over thousands of years. And so, yes, we have had changes in climate in the past. These are natural forces, and they continue today. Variations in the energy received from the sun, this has occurred historically as well, and will continue to occur in the future. Stratospheric aerosols related to volcanic eruptions. Volcanoes, when they erupt, put tremendous amounts of material into the atmosphere as well as chemicals. These generally sift out of the atmosphere in 12 to 18 months or so. So some of you may remember in 1991, Mount Pinatubo on the Philippines erupted. It actually cooled the mean temperature of the Earth for about 12 to 18 months because of all of the material it put into the atmosphere. But once that material sifted out, the global mean temperature curve continued on the trend we'd seen before. We also have things like changes in sea surface temperature associated with things like El Nino and La Nina events. A huge El Nino event is developing as we speak, and its implications for this fall and winter season are going to be pronounced in many portions of the world. So this is an area of very warm ocean current that stretches across the Pacific Ocean from the west coast of South America and so on. So they're hoping in California that this is going to put a huge dent in the drought that's been going on there for 4 years, now into its 5th year. So these are natural forces that affect climate. They've affected climate in the past, and they will continue to do so in the future. To just take one of these, and one of these myths that I showed you on an earlier slide, if you look at global mean temperature curve, this is from 1880 up to current, you can see the trend. You see the red line at the top, and you see how global mean temperature has changed over time. If you look at energy received from the sun, you see that after about 1960, we've actually had a decreasing amount of energy that we've been receiving to the sun while global mean temperatures continue to go up. So for people to say, well, the reason global mean temperature has gone up is because we've been receiving more energy from the sun, that's not true. Okay, so the fact is that in fact we're receiving less, but mean temperatures are going up. So if it wasn't for greenhouse gases and what we're doing to the atmosphere, we would actually expect to be seeing a cooling of the Earth's climate now, but that's not what we see. So if we look at the anthropogenic or human forcings to the atmosphere, we have the big one, of course, is changing concentrations of greenhouse gases in the atmosphere. We'll talk about those a bit more. We hear the most about carbon dioxide, but methane, nitrous oxide, these are also increasing, and they're actually more potent greenhouse gases. Changes in aerosol particles from burning fossil fuels and biomass. So again, aerosols in the atmosphere have an impact on the climate. Again, a human-based impact on the climate. You see the huge smoke plumes in the lower right-hand corner there. That's associated with the forest fires in 2012 during the severe drought. So, and then the third point there is related to the changes in reflectivity. I mentioned that earlier in terms of changes in land use, changes in the albedo, and so on, and how that affects changes in climate as well. Deforestation of the Amazon, for example. All of these things are examples of those kind of changes that have been going on for decades, obviously, since humans have been expanding throughout the Earth. So let's talk a little bit about, I think most of you are familiar with this concept of greenhouse gases and what role they play in this. You know that the atmosphere is primarily made up of nitrogen and oxygen, but there's this very small percentage, about 1%, it's made up of these greenhouse gases or trace gases. So carbon dioxide, again, is the one we hear the most about. And the importance of carbon dioxide and these other trace gases is that without these existing in the atmosphere, the Earth would be about 57 degrees cooler than it is. So the greenhouse gases are what makes planet Earth livable for us, for life as we know it. So the greenhouse gases are the heat regulators for the Earth. And so changes in the concentration of these greenhouse gases in the atmosphere, in fact, will change the heat balance in either direction. So if we look at the Earth's heat balance, the primary source of energy, of course, is the sun. And if the amount of energy we're receiving from the sun balances what is escaping back into space, then we have what would be referred to as a steady state. The Earth's atmosphere is transparent to short-wave solar radiation, and so it passes through the Earth's atmosphere, much like a greenhouse passes through the glass. It passes through that and it's absorbed by the Earth's surface, and when it's absorbed by the Earth's surface, it's then re-radiated from the Earth's surface as long-wave infrared radiation. The atmosphere is not transparent to long-wave infrared radiation. And so when the energy is released from the Earth's surface, land surface, water surface, and so forth, and it goes into the atmosphere, it's trapped by greenhouse gases for a period of time, which warms the Earth. So if you increase the concentration of greenhouse gases in the atmosphere, you're changing the heat balance. So you're releasing less heat back into space, and it's like putting a blanket around planet Earth. And so it's causing the temperature of the Earth to increase. And you think, well, 1% of the atmospheric concentration is these trace gases or these greenhouse gases. That's such a small percentage, but this is a really, really critical part of our climate system. And this is what regulates the temperature of the Earth's surface. So if we look at the concentrations of greenhouse gases, particularly carbon dioxide, over the last 800,000 years, you can see by the yellow line there that the concentration seldom exceeds 280 parts per million. And at the beginning of the pre-industrial revolution, the concentration of greenhouse gases in the atmosphere was right at 280 parts per million. Since that time, it's increased now to over 400 parts per million. And it's going to hit 450 and then 500 and 550, 600, and it's just going to keep going if we keep burning fossil fuels at the rate that we're doing now and not curbing emissions into the atmosphere. So when we do projections of climate into the future, we have to take into account multiple futures in terms of what will the greenhouse gases concentration in the atmosphere be 25 years from now, 50 years from now, and so on. And it's hard to project that because we don't know to what degree we're going to put controls on the burning of fossil fuels globally. So if we talk about some of the observed changes in climate, there was a paper that was written a few years ago and published in the Bulletin of the American Meteorological Society that talked about the 10 indicators of a warming world. And so those are listed here. The white arrows are where we would expect to see, if we look at the data, we would expect to see an increase. The black arrows are showing a decrease. So sea surface temperature, we should expect to see sea surface temperatures increasing. We should expect to see the temperature over land, temperature over oceans increasing, temperature near the troposphere or the surface of the Earth increasing, water vapor in the atmosphere increasing, temperature over land, sea levels should be rising because as the oceans warm, they expand, the water expands, and you also have then melting of sea ice, melting of glaciers and ice packs. and so forth, and then also a decline in snow cover. That also causes sea levels to rise. So if you look at the data behind every one of these 10 parameters, you can see this is what we see happening globally for all 10 of these. So it just reinforces the fact that the climate is changing, and we're seeing it in so many different ways in terms of the variables that we're monitoring around the globe. So if we look at the trend of global mean temperature, this is the period 1880 up to present, you can see a rather dramatic trend over that period of time, again going back to 1880. I now want to show you an animation. So what you're going to see here is global mean temperature for each year from 1884 to 2012 mapped on this illustration. So the year is going to change with this animation beginning in 1884. So the warmer areas in 1884 are the areas shown in yellow and brown. The cooler areas are those areas that are shown in blue. So as you animate this, you'll see how these changes have occurred over time. So it shows the variations from year to year in terms of weather patterns, but it also shows you a trend. So you can see how the weather varies from year to year, the weather patterns, warm areas, cool areas, and so forth. You'll see when we reach the 1930s, the Great Plains drought, the Dust Bowl, you can see how warm it was over the United States during the 1930s. So this annual variation, we're really talking about changes in weather patterns. But look what happens to the patterns when we get to about 1970. So while the graph shows that trend, here you see it more visually. And you can see that the warming that we're experiencing is greater in the polar areas than it is in the middle latitudes. In fact, the Arctic is warming at twice the rate of the middle latitudes. And that's one of the reasons why we're having a workshop focusing on the changes in the Arctic, because it's affecting severe weather and extreme weather patterns in the middle latitudes because of the temperature differential and other issues, changes in the pattern of the jet stream and so forth. So if we look at the changes that we've seen in the United States, we can see the pattern across the northern United States in terms of changes. This is based on changes or anomalies from the average from 1901 through 1960. You can see the greatest amount of warming has occurred in the western United States, which is causing a significant decline in snow accumulation, which is affecting runoff, refilling or non-refilling of aquifers and so forth, and then across the northern tier of states in the U.S. as well. One of the other indications that you've probably perceived is that if you have a stationary climate, you would expect to break high temperature records as frequently as you break low temperature records if you have a stationary climate. As I said before, we have now a non-stationary climate, and so if you look at this ratio of breaking cold temperature records versus warm temperature records, you can see how those have changed by decade. But look what's happened since the 1990s into the 2000s. And now we're breaking high temperature records at twice the rate of low temperature records. And so this has major implications for plants, animals, buildings, and so forth. If you look at how this is reflected in terms of heating demand and cooling demand, you look at heating and cooling demand from 1970 up to 2010, you can see how heating demand in the U.S. has dropped off because of warmer winters. Contrasting that with what has happened in terms of cooling demand has gone up because of warmer temperatures during the summer, more high temperature stress days, and so forth. So, you know, as part of facilities, you should be seeing these kinds of things on your campus occurring in terms of utility demand. If we look at things which relate to what crops we grow where and what we plant in our gardens as well as what we put in our landscape, this is a map of plant hardiness zones. It's looking at changes between 1990 and 2012. And so the orange line I put on the map there through the center of Nebraska, that was the division line between zone 4 and 5 in 1990. And in 2012, that zone between, or that line between zones 4 and 5, it migrated to the border of South Dakota. So we're seeing this shift, warmer temperatures, and the kinds of materials, the kinds of crops and so forth that we grow here is changing as a reflection of that. So if you look in general at Nebraska's climate, and obviously it's different for different locations, but for the state as a whole, we've seen a relatively minor increase in terms of annual mean temperature in the state so far. Most of this has been since the 1970s. So we're talking about, on average for the state, maybe only 1 degree. But we've experienced most of this warming has been with warmer winters. So much warmer winters that we've been experiencing here, particularly since the 1970s, resulting from largely higher nighttime temperatures. So in other words, minimum temperatures in the winter are higher. We're also seeing higher minimum temperatures in the summer, but it's been particularly noticeable during the winter season. A longer growing season, for the state as a whole, we're averaging about 2 weeks longer. It varies from about 1 week to 3 weeks, depending on what part of the state. We're seeing, particularly in the eastern part of Nebraska, more intense rainfall events. So this is a result of the fact that you have warmer temperatures, more water vapor in the atmosphere, therefore more energy in the atmosphere. So we're getting more and more precipitation in these high intensity rainfall events, which translates into all kinds of issues with regards to flooding, translates into issues with regards to other factors as well, how you design your storm sewer systems, for example. Annual precipitation for parts of the state, there's been a slight increase, other parts a slight decrease. As we look into the future, we're not exactly sure how it's going to change. We don't expect much of an increase in Nebraska, which is interesting because we're getting more rainfall in these high intense rainfall events, but not necessarily does that translate into a higher annual precipitation amount. I skipped the last point. Let me go back here. Just in terms of more dramatic changes in the years ahead. So from a higher education perspective, which is what we're talking about here, again, it comes down to the issue of mitigation versus adaptation. So reducing carbon emissions, reducing the carbon footprint of campuses around the state, and also at the same time while we're adapting to this changing climate. So while you folks are associated with facilities operations on campuses, this issue for higher education goes well beyond just the facilities issue, because most students, the majority of students now looking for a college to go to study, are looking at whether the campus is a green campus or not. This is affecting their decision as to where to go to college. You're going to see, and you're already seeing, a reflection in terms of the kinds of programs that universities offer, the curriculum changes, and also the kinds of majors that are offered. And there's also an important point with regards to the image of campus. In terms of universities and colleges want to be, I think, a role model for the community around them, and also the community of students in terms of being good stewards of natural resources. So things like energy efficiency are incredibly important now as well as in the future. So I want to give you just one slide because people will say, well, how do we know that the changes in temperature that we're seeing are actually reflecting human actions as opposed to natural forces? So I'll show you one slide to just try and demonstrate that for you. these computer models that we use to project future climate are also used to try and replicate past climate. So if the computer models do a good job of replicating the past climate, we have confidence that they're doing a good job in terms of projecting into the future. So this is an example of replicating past climate. So this black line here represents global mean temperature. And if you run these computer models, and the reason why you see a band there is because they run multiple computer models and they look at the output from several, not just one. If you run these computer models and you do not allow an increase in greenhouse gas concentrations in the atmosphere, it produces what you see here in green, which actually shows, if you put a trend line on this, would actually show a certain degree of cooling. If in fact you run these models and you put in the actual increase in greenhouse gases that we've seen since the early part of this century, or this last century, that what you replicate then is what's shown here in purple. So you can see the models are replicating what we're actually seeing in terms of global mean temperature. So this gives us confidence that these models are actually reliable and can be useful as we project into the future, but understanding that we don't know exactly what the concentration of these greenhouse gases are going to be into the future, because that comes down to human behavior and what we're going to see as a result of changes as we move forward. So projections for future climate for Nebraska, if you look at the projections of these models, again, they run different scenarios. So the red line represents business as usual. So if we continue to burn fossil fuels at the rate what we're doing now, we should see a pathway that looks like what we're seeing here by the red line. If we actually begin to control the emissions of greenhouse gases, then we should start to see a plateauing in terms of the changes, the degree of change that we're going to see in the future. So it's important to run the models at different scenarios, because once again, we don't know what the future is going to be like in terms of concentration of greenhouse gases. So when people say, well, the models are unreliable, that's usually based on the fact that when you look at the projections of the models and you read things in the literature, you'll see things like, well, expected changes are between this amount of change and that amount of change, so like between 4 and 9 degrees. That's not because of the unreliability of the model, it's because we don't know what the future greenhouse gas concentrations are going to be in the atmosphere. So depending on whether you take a low emission scenario or a business as usual scenario, this is going to make a difference in terms of what the future looks like in terms of temperature changes. So if we look at temperature changes across the state, the projections are, with a low emission scenario, an increase in temperature of 4 to 5 degrees. That's with low emission scenario. And with a higher emission scenario out to the last quarter of this century, we're looking at changes in Nebraska of 8 to 9 degrees Fahrenheit. So once again, related to the uncertainties with regards to future emissions. Another key factor with regards to temperature is that what's being projected by the models is a significant increase in the number of high temperature stress days. So these are days over 100 degrees. So with a low emission scenario, we're looking at 13 to 16 additional days over 100 degrees. And with a higher emission scenario, we're looking at 22 to 25 additional days over 100 degrees. We'll come back to that point in a minute. The number of warm nights increased, both in terms of winter as well as in summer. This has major implications with changing winter temperatures on overwintering of plant pests, diseases and things like that. It has huge health implications and so on. The frost-free season, if you project that out, continues to increase, perhaps by another 2 weeks or more for different portions of the state by the end of the century. And so, as an example, this is what, if you project using these computer models, a low emission scenario would have a temperature range change of something like what you see on the left at 4 to 5 degrees, and on the right you see the projection at the sort of business as usual or the higher emissions scenario. So yes, in fact, by reducing carbon emissions into the atmosphere, we can slow down and reduce the amount of warming that we're going to see. And we can make those changes pretty dramatic, but it depends on how quickly we act and go forward. So if you look at high temperature stress days, what you're seeing on this map is for different regions of the U.S. And so what you see on the brown bar here is the current average based upon 1971 to 2000. This is the average number of days for different regions over 100 degrees. So in the Southwest, be about 10. For the Great Plains as a whole, again, would be around 5 days or so. But as you move to the future, under a low emission scenario in orange and a higher emission scenario in red, you can see how those numbers of days change dramatically. So particularly for the Southwest, for the Great Plains, and for the Southeast is where you see a rather dramatic change. So if you look at and reflect back on 2012, when we had a very severe drought that affected 2/3 of the United States, and Nebraska was right in the bullseye, the core area for that particular drought. This was a somewhat unusual drought, and that normally you associate drought with a lack of rainfall, but this drought was associated not just with a lack of rainfall, but also the high number of high temperature stress days that occurred in 2012. And this was what we refer to as a flash drought, and that it came on very, very quickly, about June, and with a very intense heat and essentially no rainfall that was occurring. So if you look at the pattern of days over 100 degrees in 2012, between June 1st and September 15th, you see this pattern. So down in Texas and so on, we had close to 50 days over 100 degrees during that 2.5 month or 3.5 month period. And I've drawn out a couple of examples here. This is McCook. They had 37 degrees. Lincoln had 17 days over 100 degrees. So if you think back to that bullet point that I had a few slides back, projecting the number of additional days over 100 degrees into the future, the last quarter of this century, 2012 will basically be an average year. And I assume most of you were here in 2012, so you know what I'm talking about. So Lincoln on average has about 5 days over 100 degrees, and again 17. McCook 37, they average about 11. So this is the trend for the future. Yes, question?
Maybe you said this was the high.
Yeah.
High emission scenario. Did you say what you would have to do in a low emission scenario? Is that like carbon zero tomorrow?
No, well, not carbon zero tomorrow. I did not say to what level we'd have to reduce carbon emissions into the atmosphere. It would be substantial to get on that lower curve for the lower emissions scenario.
And the amount of time that carbon dioxide and other greenhouse gases stay in the atmosphere, is there a lifetime?
Yeah, that's, yeah, so, yeah, we have so loaded the atmosphere with greenhouse gases that even if we stopped burning fossil fuels today, globally, the temperature would continue to increase because we've loaded the atmosphere, and these greenhouse gases are going to be there for centuries. So they're not going to disappear. So there's a difference between emissions and concentrations. So we can reduce the emissions, but the concentrations are already up over 400 parts per million, and that's not going to change. But if we keep pumping this into the atmosphere, these pollutants into the atmosphere, then you're going to be on these higher temperature curves that we've been talking about. So, okay. One other critical point, just with regards to Nebraska, we depend so heavily on groundwater in the state, And if you look at groundwater level changes between the spring of 2012 and spring of 2013, you can see across Nebraska, groundwater levels dropped anywhere from 5 to 20 feet in 1 year. Now, fortunately, beginning in 2013, the drought ended for us. It's continued other portions of the country, but it ended for us. But if you think back historically, the 1930s drought, the 1950s drought, other droughts that have affected Nebraska, we're going to see more frequent, more severe, and longer droughts in the future. That's the projection from the models. And that's for many regions of the world. So this has huge implications for food security and so forth, national security issues as well. But what if the 2012 drought would have continued into 2013, into 2014, into 2015, and so on? As I said earlier, California is entering their 5th consecutive year of drought. This is not unusual. Portions of the western United States very recently have gone through 6, 7 consecutive years of drought. So as we think about the future, we were lucky with this one. It was 1 year. But if we think about this as we move forward, this is a scary picture, not just for agriculture, but municipal water supply and all kinds of other things. So for precipitation, the models are not in good agreement in terms of what's going to happen with precipitation in the future, because temperature is a continuous variable, whereas precipitation is very spotty. So it's hard to know, but in general, you can say globally that dry areas are going to get drier and wet areas are likely to get wetter. And we're going to see more and more of these intense precipitation events. So for the Great Plains as a whole, it seems like up to this point, the northern plains have been getting a bit wetter. The southern plains have been drying out, and that trend is expected to continue. There's not going to be much of a change, it doesn't look like, according to the models, in terms of the amount of precipitation we receive in winter and spring. There are some small projected changes in summer and fall, and a drying trend. The models, quite a few of the models are showing a drying trend for the central plains. So that's of concern to us as well. A continuation of the high precipitation events. And if you combine any change in precipitation, even if we get a slight change in precipitation, if you combine that with the higher temperatures and the higher temperature stress days, that essentially any increase in precipitation we might get, if we get any, is going to be ineffective because the temperatures are going to overwhelm that. Soil moisture as a result of, again, relationships between temperature and precipitation and expected to drop. We've seen quite an increase in the Midwest and the eastern part of Nebraska, eastern part of the Great Plains, in flood magnitudes, and again, this is related to these high-intensity precipitation events. Remember the rainfall we received last October in Lincoln, where we got, 6 or so inches, and we got another 7 to 9 inches in early May. These high-intensity rainfall events are just raising havoc with cities, with flood magnitudes, and so forth. So this will continue into the future. Snow cover. This is of concern because what we're seeing is declining snow cover in the western United States, almost everywhere in the western United States. So particularly in those areas that are going to feed the Platte River, going to feed the Missouri River and so on, there's less snowpack, meaning less surface water. So it's changing the hydrology of those systems, and that's going to have implications in terms of river flow across Nebraska and the Great Plains in general. So some takeaway messages. So if we talk about the impact of these changes, obviously the consequences depend upon the sensitivity of the various sectors. So some sectors are more sensitive to these kinds of changes than others. The ability of some sectors to adapt to these changes is also going to vary from one sector to another, as well as how proactive sectors are in responding to these changes. Do we wait, or do we respond now? Do we adapt, and do we also put in place mitigation measures to reduce greenhouse gas emissions so that we lower the amount of of warming into the future. And so again, this point of increasing temperatures, increasing temperature stress days are going to overwhelm any of the changes in terms of increasing precipitation if we see any at all. So these roundtable events that we're doing, these are the different sectors. And so we're now in the third one, looking at universities and college campuses. Next week we will have two, one on ecosystems, one on human health with UNMC, and then one on forest and fire, one on agriculture, food and water, and then one on energy. So certainly some of you that are part of the facilities system at different colleges might be interested in some of these others, in particular the one on energy. The Energy Research Science Center here on campus is hosting that. After we conclude these 8 roundtables, we're going to have a wrap-up session where we bring the organizers of each of these sessions together to talk about cross-cutting issues between the different sectors. Each of the roundtables will produce a report which will be based largely on the discussions in the breakout sessions that are going to occur later today. And then we will produce this report and publish this report. And then we're keeping our fingers crossed, at least at some point in the future, what we might see is a Nebraska Climate Action Plan. If you read the press releases that came out just within the last couple of weeks, there's this rural poll, rural Nebraskan poll, and it was interesting that 61% of rural Nebraskans agreed or strongly agree that Nebraska needs to develop a climate action plan. And so even though we live in a conservative, politically conservative state, people are seeing the changes and are concerned about these changes and they want to see changes. And so we're hoping to work with Senator Haar, and I think the results of these roundtables will provide a mechanism to actually begin to think about legislation associated with a climate action plan. There are about 14 or 15 states in the country that have developed these action plans. Iowa has one. Colorado just revised theirs, just came out with a new one. Most of the other states that have these are located, some in the upper Midwest and then along the East Coast and West Coast. So it's about time we fill in the central part of the country with this. So with that, I will stop and I'll give the floor back to Probs. So thank you.